Alright. I hate how it glitches like that. Sorry, guys. I don't know what's wrong with it. Alright, so let's write our language of the disciplined words. Go ahead and draw your icon. Alright. Your first word is direct variation. Direct variation. Definition is a function in the form of y equals k times x, where k cannot equal 0. A function in the form of y equals k times x, where k cannot be 0. I also want you to make yourself a little note, so I'm going to put a little star, that it can also be written as k equals y over x. So direct variation can be written in two different equations, basically. So when I talked about keeping your highlighter handy, because I want you to be able to see it when you go back in your notes, highlight y equals kx, and also k equals y over x. That's very important for you to highlight those two things. That way when you go back, we know where we got that from. So when it asks for the direct variation, it can only be written one of those two ways to solve the problem. Pencil up when you have highlighted and you're ready for the next word. Thank you, Megan and Macy and Mark. Very good. Okay, our next word is going to be constant of variation. Constant of variation. Our constant is k in that situation. So when we look at those equations, k is the coefficient or the constant of x. So we know that we have y, we know that we have x, and we know that we have k, which is the constant, the coefficient. Our next word is inverse variation. So we have direct and we have inverse variation. Inverse variation. This means an equation in the form x times y equals k, or y equals k over x, where k cannot be 0. K cannot be 0. So you're going to use that highlighter again, and you're going to highlight those two equations, x times y equals k, and then y equals k over x. So you can see when you look at both of these that they're just kind of the opposite. Okay? For this one, you're solving for y for the direct variation. For an inverse variation, you're figuring out k, and k is usually x times y. So whatever the x coefficient is, multiplied by the y, will give you the constant, which is x. And you can see this one too. When it can also be k equals y over x, and on this one you're solving for y equals k over x. So you can see that the k and the y kind of switch spots for direct variation versus inverse variation. Okay? We have two more things to write down. Thank you, Tiffany, for answering the phone. Okay, we have constant of variation for inverse variation. kind of a long word phrase. So we know what the constant of variation is. Now we need to know the constant of variation for an inverse. This basically means K is the product X times Y for an ordered pair. This will all make sense once I model for you. K is the product X times Y for an ordered pair XY. Basically means when you get an ordered pair and you multiply X times Y, that will give you K. It'll make sense once I model. All right, so let me show you a couple of examples. Okay, we're going to go with example 1. Go ahead and write that on your paper. Example 1. The directions are going to say, and write the directions so you can match with your homework which problems go with which directions. Is each equation a direct variation? Question mark. Find the constant, which we know the constant is K, of variation. Once you've written down those directions, go ahead and put your pencil in the air. Now, looking back at your vocab, at your language of the discipline, look at direct variation. What's one of the equations that it's written as? Y equals kx. So I'm going to write that on my paper just so I know. Y is going to equal kx. And this question asked me to find the constant. So what am I finding? K. Exactly. You guys are so smart. All right? So here they give us an example. 5x plus 2y equals 0. You're thinking to yourself, I have to make it look like this. So I'm going to try to get y by itself on one side of the equation. So I'm going to subtract 5x from both sides. Draw my line under. 5x minus 5x will cancel each other out. So on this side, I'm left with 2y equals 0 minus 5x is a minus 5x. I think it's over behind Shreya. All right, so now, does it look like this yet? No. So what do I need to do? I need to get rid of that 2, right? So if it's 2y, I'm going to divide by 2 on both sides. My 2's cancel. I'm left with y equals negative 5 over 2x. Does it look like that now? Yes. So, is this direct variation? That's the first part of the question. Is it? Yes, because I can come up with that. So my first answer is yes. The second part to that question, it says, find the constant, which is k. So my constant is negative 5 over 2. Does everyone see where that matches? Negative 5 over 2. And then that's my answer. So I answered both parts of the problem. Is it a direct variation? Yes, because I can make it end like this. And do I have a constant? Yes. So direct variation, to answer yes or no, it has to look exactly like this. Y equals some number x. It can't be anything else. Okay? Let's try another. I have 8x plus 2y equals 0. Now remember, I want to get it to look exactly like this. So to get y by itself on one side, I'm going to subtract 8x from both sides. Go ahead and do that on your paper. And draw the line under. 8x minus 8x cancel each other out. That's 0. So I'm left with 2y on one side of my equation, and I'm going to bring down my negative 8x, because 0 minus 8x is negative 8x. Does it look like that yet? No. So I need to get rid of that 2 to get it to look exactly like this. So I'm going to divide by 2 on both sides. 2 and 2 cancel because it's like 1y. 1y is y. Equals, what's negative 8 divided by 2? Oh, I know, that's negative 4. Negative 4, and then I have my x still. So I divided right here. Negative 8 divided by 2 is negative 4x. Does it look like that? Yeah. So yes, it is a direct variation because it looks exactly like that equation. Now the second part of the question, find the constant. My constant is k. That means it's the number that's next to x. So my constant is negative 4. And that's my answer. Not bad, right? Cool. So again, when you talk about direct variation, write down that equation first so that you can make sure it looks exactly like that. Let's take a look at one more just like this one. Y equals 3/4 x minus 7. Just take a second to write that down. Do we have to do anything? Is y already by itself? Yeah. Right? Because look, we want it to look like that. But wait a minute. Can I do anything with this 7? Why is this 7 here? Does that look like this equation? So is it a direct variation? So my answer is just no. Nope, my answer is no. And I can't give you a constant because I have that negative 7 that's hanging around my equation. It's not going to work. So when you find stuff like that, that's easy. But you have to make sure that the equation looks like this. If there's something tagging along at the end, it's not a direct variation. Okay? Uno más for this type of example, and then we'll move on. X minus 3y equals 6. Okay, I can work with this one because y is not by itself yet. So let's get x out of the picture. So I'm going to subtract x from both sides. Let's bring that x over to the other side of my equation. So positive x minus x cancel each other out. So I'm left with negative 3y on one side of my equation, and I'm left with negative x plus 6 on the other side. Now you can do 6 minus x, but it'll give you an extra step in the problem. So do negative x plus 6. It's the same thing. It just leaves out one extra step. Alright, so I'm going to need to get y by itself so that the equation looks like the direct variation equation. So I'm going to divide by negative 3 on both sides. My negative 3's cancel. I'm left with y equals. Now, that's like saying negative x over negative 3 plus 6 over negative 3, right? So y equals, let's see, that's like an invisible 1 here, remember? So that's going to be positive 1/3 x plus 6 divided by negative 3 is negative 2. Oh, there's a plus and minus next to each other. So y equals 1/3 x minus 2. So when you get to this part of the step, remember that you have to split it up like it's two problems. So that's where I get my negative 1x over negative 3 plus 6 over negative 3. And I'd solve them separately to get my final answer. But now, does that look like a direct variation? No, because what's lingering around? That negative 2. So my answer is no. Nope. It is not. Pencil up when you've written that down. And if you have any questions, you can ask me at the end, okay? All right. Very good. Let's try example 2. The directions say to write an equation of the direct variation for the given point. Write an equation of the direct variation for the given point. So they're going to give you a coordinate. We have to plug in x and plug in y and then solve. When you have the directions written, put your pencil in the air. Thank you, Shreya and Dane and Cloyce, Daniela and Elizabeth and Alex. Very good. So let's try the first one. They're going to give us 4, negative 3. Now, what type of variation are they asking us to write? Direct or indirect? Direct. So I know, because I'm going to write it down, that means that my equation has to be this. Right? Because in your language of the discipline notes, it tells you what the equation is, right? Direct variation tells you right there. There's the equation. Y equals kx. All right, so now what you're going to do is you're going to plug in the coordinates. So what's my x and my coordinate? 4. What's my y? Negative 3. So I'm going to plug that in. So y is negative 3 equals k. I don't know what k is. And x is 4 times 4. Makes sense? Just substitute it in. Okay, so you know what? Let's go ahead and write the steps for this equation, or for this one, down on the right-hand side. So step number 1, make sure you always write the equation. You have to determine, is it direct or indirect? Write the equation. And then we just did step number 2, substitute. Substitute. So we substitute them in. Now the next thing we're going to do is we're going to solve step number 3, the equation. So what letter am I solving for? K. All right, I can do that. That means I need to isolate the variable. I need to get k by itself. All right, so that means if k is next to 4, their multiplication, I'm doing the opposite. So I'm going to divide by 4 on both sides. My 4's cancel over here, so k is left. And I have negative 3 over 4. So k equals negative 3/4. Now that I've found k, look back at the directions. It wants me to write the equation. So I have to make this look like this equation right up here. Okay? So how am I going to do that? Easy. Y equals, now that I have k, negative 3 over 4x. That's my answer. Because they don't want to know what y and x are. You found out what k was, but they just want you to write it in the equation that looks just like this. Y equals kx. So you're basically finding k so you can rewrite the equation. So step number 4 was to plug the number 4k back into the equation. It's very important for you to write this step down. Because if you don't write that step down, you're going to end up giving me an answer, k equals 3, negative 3 over 4. That's not what they're looking for. They want you to plug the number back in for k into this equation. Kinda, sorta. You find k, put it back in the equation. All they want is the equation. Okay, let's try one more. Two more. They give us 3, 2. And I know myself. I'm going to write down the equation every time so I don't forget. Y equals k times x. That way I know this is what I need to write when I get to the end. Alright. Alright, so I'm going to plug in y, which is 2, equals k, which I'm trying to find out, and x is 3. Okay, so I need to get k by itself, so I'm going to divide by 3 on both sides. 3 over 3 cancels. K equals 2/3. Am I done? No, I got to plug it back in to the equation. Alright, so here's my equation. Y equals kx. Y equals, oh, I found k, 2/3 x. All they want is the equation. That is your final answer right there. Last one for this example, and then we'll move on. Negative 30, comma, negative 6. And again, I know myself, so I'm going to write down the equation, y equals kx, so I don't forget to write that at the end. Scram, don't forget to write it like that at the end. Okay. So plugging in y is negative 6. Now don't make the mistake of plugging in x. Make sure you plug in y first, which is the number on the right-hand side. Equals k, which I don't know, times negative 30, which is x. Need to get k by itself, so I'm going to divide by negative 30 on both sides. Negative 30 divided by negative 30 is 1. So they cancel because that's like 1k. K equals. Now I have a positive 60 over 30 because 2 negatives divided by each other is going to give me a positive. Now I need to simplify. Exactly. So I'm going to divide the top and bottom by what number? Probably 6, right? And so I'm going to get 1 over 5. K equals 1/5. Alright, we found k. Are we done? No. Write it in the equation. Y equals, k is 1/5, x. All they want you to do is find the equation. It's very simple. Pencil up once you have written that down. Take your time. Okay, so that's another type of example. Okay. Example 3. The directions say tell whether y varies directly with x. Second part, write the equation. There you go. Tell whether y varies directly with x. Write the equation. So this is going to be where the other direct variation equation comes in. So we use the y equals kx, but if you look back at your language of the discipline, it says it can also be written as k equals y over x. So this is the time that we're going to use y divided by x. Now the way that they are going to do this type with you is they're going to give you a graph first, okay? Or a table, I should say. So they're going to give you x. They're going to give you y. And then you need to find y over x, which is the other way of writing a direct variation. So for x, they give you 4, 8, and 10. For y, they give you 6, 12, and 15. Miss Graham, what do I do next? You literally, all you have to do is write y over x. You just have to divide it. So I'm taking y, 6, over x, 4. And what's 6 divided by 4? It's 3 over 2 when I simplify it, also known as 1 1/2. Do the same thing with the next one. Take the y, 12, over, take my x, 8, simplify it by 4, I'm going to get 3 over 2. That's also 1 1/2. I see some sort of pattern going on here. Let's try the last one. Take y, 15, over 10, which is x, equals 15 divided by 10 simplified. I'm going to take 5 too. I'm going to divide 15 by 5 and get 3. I'm going to divide 10 by 5 and get 2. Oh, wait a minute. They're all the same. When every single row has the same outcome, it's a direct variation. So my answer is yes. It is a direct variation. That's the first part of my answer. Now it wants me to write it in an equation. What's that other equation again? It's y equals kx. That's how they want me to write it. So I'm going to write y equals, you can do 1 1/2 or 3 over 2. I'm going to make it a decimal. 1.5, because that's what we found here, x. And that's my final answer. So just to reiterate again, what I am putting right here when I write the equation is what's right here, this number. So you know where it comes from. Now again, you can write it in many ways. You can write it as 3 over 2x. That's completely fine. Or you can write it as 1.5x, 1 1/2x. Either answer is correct. Put your hands on your head if that makes sense. Does? Okay. Here's another. Letter B. X, y, and y over x. In this one, the x is -1, 1, and 2. And the y is 2, 2, and -4. Go ahead and write those down. Okay, then you're simply going to put y over x. So for my first one, my y is 2 over -1. Oh, that equals -2. That's easy. I know that. And try the next one. 2, which is my y. My x is 1. That's a +2. Ooh, I already see a problem. Do they match?
No.
Okay, well, let's see the second one, or the last one. Taking y, negative 4 over x 2. Oh, that one equals negative 2. Do all three match? No. So is it a direct variation? All you have to do is write no. That's it. If they don't match, no is your answer. Okay, last one of this type of example. I know there's a lot, guys. Sorry. You have to get through it. X, y, and y over x. Go ahead and set up your table. For x, I have 4, 7, and 10. For y, I have 8, 14, and 20. And I know you all are very smart, so you can already see the pattern, can't you? Yeah. Y over x. 8 divided by 4. Oh, that's 2. Easy. Let's try the next one. 14 divided by 7. Oh, that's 2. I see where this is going. 20 divided by 10. That's 2. Remember, everyone should be writing with me, so if you don't have a pen in your hand or a pencil, I'm a little skeptical. Alright, so we do see a pattern. We see that we get 2. So is this a direct variation? Yes. Now I must write the equation. And my equation is y equals k times x. So how do I write that? Y equals, what's k? 2x. Done. So once again, this number right here is the same as these here. Alright, those are the examples of direct variation. Now we got to do indirect. Not as bad though. Not as bad. Pretty simple. Okay? Here we go. You guys are troopers. Go ahead and stand up and stretch for a second. Take a 7th inning stretch. Stretch your arms to the sky. Touch your toes to the floor. And we're going to keep going.
So we're 70% done.
Yep. Almost there. And you're back in your seat in 5. In 4. In 3. In 2. In 1. Good. All right, here we go. You guys can do it. This says to write. Talking is done. An equation for the inverse variation. Please write those directions down. Now we're doing inverse. We're going to do 3 examples of inverse and we'll be done. So we're on example 4. We're going to have to get to example 6. Almost there. Whew, I know, but it's 2 sections in 1. We can do it. Okay. The first question says, y varies inversely with x. Y equals 7 when x equals 5. Y varies inversely with x. X equals 7 when, y equals 7 when x equals 5. If I go back to my language of the discipline, now I'm at a different equation because we're talking about inverse. So when I go back and look at inverse, it's one of these two. Okay? These types of questions where it gives you x and y, we're going to use this equation right here. Y equals k over x. So go ahead and write that. Y equals k over x. And highlight that for this example. So that's what we want it to look like. Alright, so all you have to do is plug it in. We want it to look like that. So what's y? 7. So 7 equals, what's k? Oh, they didn't give us k, so we don't know that. Over, what's x? 5. Okay, not too shabby. I need to get k by itself. To get k by itself, I'm going to multiply by 5 on both sides. Because it's division, so you do the opposite, multiplication. So my 5's cancel. K equals, what's 5 times 7? 35. And it's just like the other question. I don't want to give you what k is. That's not your answer. I want you to show me the equation. So all you have to do is plug k in. Y equals k, 35, over x. Done. They just want the equation at the end. So your first step is find k. Nope. Wait after. Second step is put it in the equation. Okay. That was example A. Oops. Here's example B. X equals 3/4 when y equals 2/9. This should be interesting. This is what I want it to look like, correct? Yes, Miss Grant. Awesome. So y is 2/9 equals, is that going to work? 3/4 or k over 3/4? Can I write my equation like that? No. So then I'm going to look back and say, you know what? I'm going to try this one because there are two equations I could possibly use. So my other equation that I could possibly use is x times y equals k. Highlight that because that's the second type of equation you can use. So I'm going to use that one because that one seems like it works better. So x is 3/4 times y, you're writing with me, which is 2/9 equals k. That one seems to work out a lot better. So when I multiply, I'm going to go straight across. 3 times 2 is 6. 4 times 9 is 36. Simplify it by dividing by 6. K equals 1/6. I can't stop there. I just put it back in the equation. What's the equation that I used? xy equals k. So I'm going to write xy equals k, which is 1/6. That's it. You just plug it back into the equation. So for inverse, there are two equations you can use. For direct, there are two equations you can use. That's why we highlight them so we know what they are. Mr. Martin, hurry up and use the restroom. Okay, example 5, we're almost there. Woohoo! This one's my favorite because I think it's super easy. Find the missing value of the inverse variations. Find the missing value of the inverse variations. So for this one, they're going to give you 2 coordinates. So for my first one, they're going to give me 3, y and 5, 9. For this one, you're literally going to multiply the x and the y. So your equation is going to be x1 times y1 equals x2 times y2. Huh, Miss Graham? It basically means you're going to take x times y equals 5 times 9. So my first x is 3. Y, I don't know, so it stays y. My second x is 5. My second y is 9. So now they're multiplication problems. 3 times y is 3y. 5 times 9 is 45. So all you're doing is setting them up equal to each other and multiplying on each side. Easy. Then you just divide by 3 and get y by itself. So I'm going to divide by 3. Divide by 3. My 3's cancel, and y equals 15. That's my answer. You're just finding the missing point. Easy enough, right? You just set them up equal to each other, multiply, solve for y. Okay. What about 5, 8, and 4m? So again, I'm going to take x1 times y1 equals x2 times y2. That's easy. 5 times 8 equals 4 times m. Five times 8 is 40. 4 times m is 4m. Solve for m. Divide by 4 on both sides to isolate the variable. M equals 10. Now you know why I like these ones. They're just so easy. They're already set up for you, basically. Put your pencil up when you got that. Golden, you guys are troopers. You're troopers. Almost. Hey, I'm giving you as many examples as possible so you have no questions. Here, go ahead and set that one up on your own. Shh. Look at the last two we just did. Set it up. When you set it up, does it look like this? Okay, then we're going to go further. 25 times 100 is 2,500 equals 4 times 9, which is what? 4 times 9, anyone? 36. Good. Oh, whoops. That's an A. Oh. Sorry. 4A. A's and 9's look alike sometimes on graph paper. Okay, so then I divide both sides by 4 to get A isolated. A equals 2,500 divided by 4, 625. And that's my answer. All right, we did it. We were making it to the last example. Oh my Lord, woo! Example 6, the last one. Example 6 basically asks you, does the data represent, you can do it, a direct or inverse variation? So they're going to give you some sort of graph, and you have to say, is it going to be direct or indirect? So your answer is going to either be inverse or direct. Get used to it. In high school, you take notes, and then you just leave the whole class. Okay, so the first one looks like this. They're going to give you X and Y And they're going to give you, that's it, x and y. 2, 7, and 10, 35, 10, and 7. What you have to add to your graph is the two types of ways to find out if it's direct or inverse. Now we know that if it's direct, it's going to be y over x. The y's over x's are going to be the same. But if it's inverse, the x times the y will be the same number. Kind of, sort of. So I'm going to take the first one, 35 divided by 2, my y over my x. Can I simplify that? No, right? Okay. My next one's going to be 10 over 7. Can I simplify that? Is this going to work? Am I going to come out with the same number every time? So draw an x. That's not going to work. So it can't be direct. Direct doesn't work. This is a direct. Right here, this is direct. That direct isn't going to work. Let's see if inverse works. X times y, all right? 35 times 2, or 2 times 35. That equals 70. Okay. Try the next one. 7 times 10. Oh, that equals 70. Let's try the last one. 10 times 7. Oh, that equals 70. So are these points direct or inverse? Inverse. That's your answer. Inverse. Simple. Last one. One more. Last problem. This is the last example. Here we go. They're going to give you the x and the y. So I have 5, 6, and 8. And I have 55, 66, and 88. You can probably already tell what it's going to be. What are the two things I need to add to the graph? Y over x, which is direct, and x times y, which is inverse. So I'm going to put a D so I remember this is direct, and then put an I so I remember that's inverse. Okay, cool. Let's see which one works. Alright, y over x. I have 55, which is y, over x, which is 5. 55 divided by 5 is 11. Okay, let's try the next one. 66, which is my y, divided by 6, which is my x. And that equals? Oh, good. 88 divided by 8 equals 11. So is it direct or indirect? Or inverse? Direct.